Good morning, grade 9s. So up until now, we've been discussing finding the highest common factors of two numbers. In the previous video, you would have seen that they were showing you how to find them for two monomials. So basically things with coefficients and variables, or numbers and letters. So what we're going to do is do a couple of examples. So this video, we're going to do 4 examples of how to actually calculate this. So we're always going to follow 3 steps. We're going to first look at what is the highest common factor between the numbers. So what is common between the numbers? Then we're going to look for the common variables, as in, are there the same letters in both? And then we're going to choose the exponent that goes with the variables. And it's always going to be the lowest exponent of the two. So let's, excuse my sniffing, let's do a couple of examples to make sure that we understand what that is. So first, let's start with the numbers. So I'm just going to highlight, here's our one number, here's our other number. Alrighty. So this one, hopefully, is pretty easy. So I'm going to say the highest common factor between 2 and 2. So let's just look at the numbers. So what is the highest common factor? Well, 2, right? 2 goes into 2 and 2 goes into 2. So when it's the same number, your highest common factor will always be the actual number. All right, now let's talk about the variables. So the variables that we have here are a squared and we have a b. So which letters do we have in common? Well, they both have an a, so that's pretty helpful, but they don't both have a b. So b is not a common variable. All right, now the third step was to say, well, let's assign the lowest exponent. Well, if we remember correctly, the exponent here is actually a 1. So even though it doesn't actually have a number, we know it's a 1. So what's higher? What's lower, 1 or 2? Well, obviously 1. So we can either write that there, or we can just leave it as a. So we put those two together, and then our final answer will be, well, the highest common factor is 2a. And that means that I can actually divide 2a squared by 2a, and I can divide 2ab by 2a. Remember, a factor needs to leave no remainder, which means we can divide it into it. All right, so that's our first example. I hope that makes sense. So first, find the highest common factor of the number, then find which variables are common between the terms, and then lastly, assign the lowest exponent to that variable. All right, let's try example 2. We'll hide example 3 for now, just so we don't get ahead of ourselves. All right, so let's look at our numbers. So we've got a 3 and we've got a 2. And if we think about this, let's think of all the factors of 3. So 3 is already a prime number, so I know that it's just 1 and 3. Then let's look at the factors of 2. Well, I know that the factors of 2 is just 1 and 2 because, again, 2 is a prime number. So here, the highest common factor that we have is just 1. They don't have anything else in common. So our HCF in terms of the numbers is going to be 1. All right, now let's discuss the variables or the letters. Please notice that we're going to start just saying variables. All right, so we have the variables m squared and we have the variables m. Now, first question we ask ourselves is, what letters do they have in common? Well, we can see it's an m. There's an m in this one, and there's an m in this one. And then third step, let's assign the lowest exponent. Again, we can see that this exponent is a 2, and this exponent, because there's nothing there, oh my goodness, this exponent is a 1. So we ask ourselves, what's the lower of the two, 1 or 2? Obviously it's 1, and we can actually just write that as m. So that means that the highest common factor of these two monomials is actually 1m. But because we're getting really good at our algebra, we know we don't have to write that 1, so we're just going to say our common factor is m. The only thing that we can divide both of them by is m. All right, so let's go on to example 3 here. Oh, this one looks more interesting. So let's look at our numbers. Okay, so we've got 33 and 27. Now, There's a few ways we can do this. I'm going to just go the typical prime factorization route. You guys can choose whichever method you like. If you know it out your head, good for you. Just make sure that it's your highest common factor. So I'm just going to do prime factorization just as a reminder. I'm going to grab my calculator here in case I need it. So I'm going to say, okay, what is the smallest prime number that goes into 33? Well, 2 doesn't go in there, so it's 3. 3 goes into 33. 11 times. 11 is a prime number, so there you go. 11 goes in there once. So actually, I can write 33 as 3 times 11. All right, now let's try 27 over here. Smallest prime number that'll go into 27, 3 again. 3 goes into 27 9 times. 3 goes into 9 3 times, and 3 goes into 3 once. Which means that I can write 27. Actually, let me move this underneath here. So I can write 27 as 3 times 3 times 3. All right. So now we're going to say, all right, so to our highest common factor, we look at what they have in common. Well, they only have a 3 in common. Do you see that? So the highest common factor for the numbers is going to be 3. All right, so now let's go to step 2, which is the variables. So our variables, fix that, it looks more like it says variables. Okay, variables, there we go. We have x squared y, and we have xy squared. So now we're going to ask ourselves, what do they have in common? Well, I can see that they've both got an x and they've both got a y. So we've got x and we've got y. Now we need to ask ourselves, what is the lowest exponent? And again, this y doesn't have an exponent, so actually it's 1, and this x doesn't have an exponent, so actually it is 1. Remember, this 2 is only applicable to the variable that's next to it. So this is y squared, not x squared and y squared. All right. So the lowest exponent here is for x, we've got 2 and we've got 1, so it's just 1. And for y, we've got 1 and we've got 2, so it's just 1. So technically, if we combine this all together, our highest common factor for 33x squared y and 27xy squared is 3xy. So I think it's pretty cool that you can take something that looks complicated like that and find the highest common factor. All right, so now we're going to head on to our last example. This one looks pretty tricky too. Let's see how it goes. So just like before, let's start with just our numbers. I'm going to do my prime factors again, just because I think it's really good practice for us to be doing that. So I'm going to say 16, and I'm going to say, okay, 2 goes into 16 8 times, 2 goes into 8 4 times, 2 goes into 4 twice, and 2 goes into 2 once. Cool beans, I now know that 16 can be written as 2 times 2 times 2 times 2. So that's 1, 2, 3, 4. 1, 2, 3, 4. Good check. All right. So then let's do the same for the number 32. Well, 2 goes into 32 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. 2 goes into 4 twice, and 2 goes into 2 once. Alrighty, so that means that I can say that 32 can be written as 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so now let's see what they have in common with each other. So these they have in common. All of these they have in common. All right, so let's see here. The highest common factor is going to be all the things that they have in common multiplied by each other. So let's have a look. Okay. 2 times 2 is 4, times 2 is 8, times 2 is 16. All right, so the highest common factor for the numbers is 16. Now, we can always double check. We can grab our calculators and say, look, does 16 go into 16? Yes, it does, one time. Then we can say, does 16 go into 32? And we put in our calculator, 32 divided by 16, boom, twice. So we know for sure that it's right. All righty. Now, let's have a look at our variables. Okay, we've got x to the power of 4 and y squared. And then the other one, we've got x squared y. All right, so here's an x, so cool, they both have an x. Here's a y, they both have a y. That's step 2, finding which letters they have in common. Now, step 3 is going to be, let's write the lowest exponent for each of these. So let's look at this x, and that's x to the power of 4, and then x to the power of 2. Well, which is lower? 2. So there we go. Here we've got y to the power of 2, and hopefully you remember this by now, y to the power of 1. Okay, so we ask ourselves which is lower, a 2 or a 1? And we see that our answer here is 1. So technically, our highest common factor for these two, we put our number and our variables together, and it's 16x squared y. Now, what I want you to do is I want you to go through these examples we've just done really slowly. Write them down if you need to. In fact, if you've got your textbook, you can write them in there, you can fill them in there if you'd like. So that's as simple as it is, I think. If you're struggling with this, please don't struggle on your own. Let me know. Send me a message via Classroom or via email, whatever you need to do. The most important thing is to remember the 3 steps. 1, find the highest common factor of the numbers. 2, find which variables or letters there are in each of the terms, so what they have in common. And then 3, write the lowest exponents for each of those variables. And hopefully it'll be as easy as that. All right, good luck with your exercise, and I'll see you guys tomorrow. Bye.